Hey guys, so let's continue our review of what we've done this year by moving into Module 2. So Module 2 was a lot about the number system with a strong focus on how do we do operations such as adding, subtracting, multiplying, dividing when we've got more complicated numbers involved, specifically speaking when we've got to deal with negative numbers. We did a little work with fractions and mixed numbers as well, but it was mostly about like what do we do with positives and negatives. And so where we started was let's add positive and negative numbers using everybody's favorite, vector models. Remember, vectors are those arrows that point, well, vectors are used for tons of different things in math, but where we use them was to point in different directions and lengths on the number line. So let me draw a quick little number line here. I'm not going to do anything too complex. We'll make this pretty simple. I'll put a 0 here, 1, 2, 3, 4, and we'll put -1, -2, and -3 over here. And let's say I wanted to make a vector model for, how about 3 plus -5. And I always start my addition models, my vector models at 0 because that's sort of like the basis of all operations. And then we show that it's like we're starting at 3, but also you could think of it as this is the operation 0 plus 3 plus -5. So we got our first vector going from 0 to 3. Or in other words, it has length 3 and it's pointing in the positive direction to the right. And then we start our next vector at 3, and we're going to go 5 units to the left. And we count as we go. We're going, okay, 1, 2, 3, 4, 5 units stops us right here at -2. And so that means that the sum in this case, 3 plus -5, equals -2. And so these vector models were designed to help us realize that anytime we add a positive number, we wind up going to the right or more positive. And every time we wind up, or every time we add a negative number, we wind up going to the left or more negative. And there was one kind of important thing to see about that well, actually there was like two. So this helps with one. Let me draw another vector model real quick so that I can refresh your memory on this other thing. So I'm just going to do another one real quick. This time I'm going to put 0 way over here, and I'm going to focus more on the negative numbers this time. So -1, -2, -3, -4, -5. And let's say I wanted to do -2 plus -3. And so I'm just going to start my first vector at 0. It has length 2 and it's pointing in the negative direction, so it gets me to -2. I start my next vector there and it has length 3 and it's pointing in the negative direction as well, and so it gets me to -5, and so the sum in this case is -5. And by looking at these two diagrams, a couple of tricks for quickly adding negative numbers came out of these that you were supposed to try to remember. And so there was a trick that came out of this purple model up here. I'm going to use a different purple because that light purple is starting to run a little low on ink. So the trick from this was when adding a positive plus a negative number. Well, whether you ended to the right or to the left of 0, or in other words, whether your sum was positive or negative, was determined by which of these vectors was longer, right? In this case, the vector pointing in the negative direction was longer, and so our sum wound up negative. And so, in other words, whichever number is bigger, right? Now I'm using quotes when I say bigger because positive numbers are always bigger than negative numbers, but I'm really referring to their absolute values, right? How far from 0 they get you. So in this case, the absolute value of -5 is bigger than the absolute value of 3, and so we wound up in the negatives. So, and then how far in the negatives did we wind up? Well, we wound up 2 spaces in the negatives. And that's the difference between these absolute values, right? If we just forget about the negatives and we just think of 5 and 3, well, the difference between 5 and 3, or in other words, 5 minus 3, is 2. So we know that because the difference between these absolute values is 2, we're going to wind up 2 spaces from 0. And because the negative number has bigger absolute value, or it's bigger, right, that we're going to wind up on the negative side. So we wind up at -2. And so we could use this trick. When you're adding a positive and a negative, the bigger addend, remember addend means just a number you're adding, and I'm going to put bigger in quotation marks because I'm really talking about absolute value. So I really should say the addend with larger absolute value or greater absolute value determines sign of sum. That's just a fancy way of saying determines whether or not the answer will be positive or negative. And then just subtract. So this is like, there's like 2 parts to this. Subtract the addends. Absolute values, I should say. You subtract their absolute values. So let's try a couple of them. Let's say I needed to do 10 plus -7. Okay, let me look at their absolute values first. 10 and 7. 10 is bigger, that's the positive number. So my answer to this is going to be positive. Now let me just subtract them. 10 minus 7, 3. All right, the answer is positive 3. All right, let me try another one. What if I needed to do -9 plus 5? All right, let me look at their absolute values. I got 9 and I got 5. Well, the 9 is bigger, so that means the answer to this one is going to be negative. So let me just put my negative sign there already. Okay, now let me just subtract them. 9 minus 5 is 4. So to the answer to that one's -4. All right, and then with the red one, a trick also came out of this. Well, you should notice that when you add up 2 negative numbers, both vectors just push you farther in the negative direction on the number line. So it's the same as if you added 2 positive numbers. Both vectors would just push you farther in the positive direction, right? So it's literally the same as adding 2 positive numbers, except you just throw a negative sign on there. Okay, so when adding 2 negative numbers, just add their absolute values. That's the same as just saying add them as if they were positive, just forget the negative signs. And then put a negative sign on the end, on the answer or on the sum. Negative sign on the sum. So for example, if I needed to do -4 plus -11, I'm just going to do 4 plus 11, which is 15. Put a negative sign on there. I'm good. All right, if I needed to do -3 plus I don't know, how about 78? Well, I'm just going to do 78 plus 3, which I know is 81. Toss a negative sign on there. All right, so then we had to talk about subtraction. And the first thing I told you is that subtraction is just a big old lie. It's a lie that's been, I don't know, forced upon you since whenever. And that's a big old joke, but what do I really mean by that? What do I mean by subtraction as a lie? Well, subtraction is just adding the additive inverse, also known as just the opposite. Right, when you're subtracting a number, like when you write, I don't know, 8 minus 6, you could almost just think of this as shorthand for what you're really saying, which is 8 plus -6, right? This subtraction operation is really just an addition in disguise telling you to add the opposite of what you see. And so the hardest thing about this is how do we handle subtraction of a negative number, right? What if I need to do 8 minus negative 6? That one's weird. And so there's lots of different ways to conceptualize what it means to do 8 minus negative 6. Or like I have positive 8 things and then I take away 6 negative pieces of it. And so if you think of like taking away 6 negative, that's like getting 6 more positive, right? And so we would practice changing a subtraction sign wherever you hear the word minus. 8 minus negative 6, I'm going to change minus to addition. But wherever you change subtraction to addition, you must invert the next number. This negative 6 must become positive 6. And so the difference in this case, because you're subtracting, is 14. All right, and so then we moved on to multiplication. And I showed you this thing here. Let me write multiplication here. And we would put a plus sign at this triangle and negative signs down here at the bottom. And the idea with this triangle is that if you're multiplying two numbers, you just cover up the two signs of the things you have, and then the one that you can still see is what the answer must be. Notice there's no two plus signs, so you can't cover up two plus signs if you're doing two positive numbers, but I think we're all pretty like confident that a positive times a positive is a negative, right? But let's say you can't remember, wait, a negative times a negative, what's that? Well, cover up the two negative signs, and you can still see the positive sign. So that reminds you that a negative times a negative equals a positive. Well, what if I'm doing a negative times a positive? Okay, well, I'll cover up the negative and the positive, and that reminds you that a negative times a positive is a negative. And so we talked a little bit about like why some of these are true. Why is it that a positive times a negative equals a negative? Why is that? Well, multiplying by a positive is just repeated addition, right? Multiplying by a positive is repeated addition. And so let's try a couple. If we wanted to do 4 times negative 5, well, that's just like adding negative 5 to itself 4 times, right? So what we have here is negative 5 plus negative 5 plus negative 5 plus negative 5. And since we had just been practicing adding these negative numbers all the time, and we know that if we're just adding negative numbers over and over again, we can add them as if they're positives or add their absolute values, right? So 5 plus 5 plus 5 plus 5 is 20, and then throw a negative sign on there. Remember, that trick only works if every single addend is negative. As soon as you throw one positive one in there, you can't use that trick anymore. All right, but then the weirder thing is, like, why is it that a negative times a negative is a positive? And remember, we spent like several days talking about this. We did that thing where there was number lines made out of tape on the floor, and you had to, because the first number was negative, you had to face backwards, and then because the second number was negative, you had to walk backwards, and doing those two things forced you forward on the number line. And then I did this other thing. I said, okay, so we're talking about y is a negative times negative is equal to positive. Well, I said one way you could think about it is that multiplying by a negative sort of does the opposite of what multiplying by a positive does. If multiplying by a positive is repeated addition, you could think of multiplying by a negative is repeated subtraction. And so what if we took this exact same question up here, 4 times -5, but turned it into -4 times -5? And so if we're doing repeated subtraction, well, when you're doing subtraction, you got to start from somewhere, right? We always start from 0. So let's start from 0 and then repeatedly subtract -5 4 times. So minus -5, minus -5, minus -5, minus -5. And then we had just already learned that subtraction is really just adding the additive inverse in disguise, right? And so, well, that means that this minus -5 is really plus +5, and minus -5 is really plus +5, etc., etc. And so we wind up actually at +20. And then I did that proof for you that looked like this. I'm not going to redo this whole thing because I think most people don't even really understand it anyways. But just to like jog your memory to be like, oh yeah, I kind of remember that. I said, well, we know that 1 minus 1 equals 0. Everybody agrees that. And we can rewrite that as 1 plus -1 equals 0. And then I can put those things in parentheses without changing the values, right? 1 plus -1 in parentheses equals 0. And since this stuff in the parentheses equals 0, I can multiply it by any number I want and still get 0. So -1 times the quantity 1 plus -1 still has to equal 0. And then I distributed the -1. -1 times 1 equals -1, because 1 times any number equals itself, plus blank equals 0. And whatever goes in the blank has to be -1 times -1. Well, I'm going to let you think about it logically from here. What has to go in that blank in order for -1 plus blank to equal 0? And whatever goes in that blank has to be whatever -1 times -1 is. And so just through sort of a logic-y, weird way of thinking about it, it sort of forces your hand into making a positive answer there, I believe. All right. So yeah, there's module 2 in a nutshell. And I'd like you to practice a little bit of these just to get them fresh back in your brain. All right. See ya.